Hello students, this is Sir Shakil and today we are going to discuss a very important topic from IGCSE physics, that is pressure. Okay, so let's first look upon the syllabus points. In the pressure, we'll be looking upon the general pressure equation, which is P equal F over A, and then we'll be looking upon mercury barometer used to measure atmospheric pressure. We'll be looking upon liquid pressure, and we'll be looking upon manometer, and then we'll be using the liquid pressure equation. Okay, first of all, we have to look upon pressure. So the definition is quite simple. It is force acting per unit area of object. So force acting per unit area of object is known as pressure, and it is force over area, or P equal F over A. That is the equation for pressure. And the SI unit for pressure is Pascal. So 1 Pascal equal Newton per meter square, or 1 Pascal equal 1 Newton divided by 1 meter square. If we have to define Pascal, we'll define it as 1 Pascal is the amount of pressure when 1 Newton of force acts on an area of 1 meter square. Okay, now let's talk about the factors for the pressure. As you know that factors are the quantities that can affect the value of pressure, and that comes from the equation. So the pressure is directly proportional to force according to the equation, or weight, if you keep the area constant. Okay, secondly, pressure is inversely proportional to area if you keep force constant. It means that if you keep on increasing the weight or the force, pressure will keep on increasing. And on the other hand, if you increase the contact area, the pressure is going to decrease because this is inverse proportionality. Now let's look upon the example. In example 1, there is a surface on which an object of weight W is placed. If you, and let's say the pressure with W is P. If you put another block of the same weight on it, then of course the weight will be doubled now, but the contact area would be same. It means the weight is 2P, so pressure will also be increased. If you place another block on top of it, of course, another weight W would be added. So now total 3W weight is acting through the same area. It means the pressure will be increased 3 times. So that's the factor number 1, that pressure is directly proportional to force, keeping the contact area constant. Okay, in the second example, there is a block of dimensions L, which is length, W, which is width, and H is height. So it is placed in 3 different positions. The first position X, the second position Y, and the third position C. So in this, its weight is constant, like weight or the force is constant. You are not changing it, but the contact area is changing, right? And as we know that pressure is inversely proportional to area, so the position where contact area is maximum, pressure would be minimum. So the minimum pressure would be at X and maximum pressure would be at Z. So pressure at Z is maximum because its contact area is minimum. Like this is the contact area, which is the minimum contact area. And over here, this is the contact area. And over here again, this is the contact area. And then pressure at Y, and then pressure at Z. So as, sorry, not Z, it's X. So pressure at X is least because length into width both are the bigger side, so it's having the greater area, so less pressure. And pressure at Z is maximum because the area is minimum. Okay, now let's do another example. You have to solve it. You can pause the video and just look at the question and try to solve it. There's a brick of mass 10 kg. Its dimensions are length, width, and height, which are given as 20 by 10 by 5 centimeter. Like length is 20 centimeter, width is 10, and height is 5 centimeter. What you have to do is you have to find maximum pressure and minimum pressure that brick can exert on ground. Well, for maximum pressure, we have to see that the weight will be constant. So if you want to find maximum pressure, the area, well, the area can be changed over here. So we know that pressure is inversely proportional to area. So for maximum pressure, you have to use minimum area. And F will be the weight of that brick. So weight is mg, 10 is mass and 10 is g. And then area, you have to convert it into meter. So the minimum area is obtained when you multiply 10 and 5. This would be for the minimum area. So you have to divide them by 100 to convert them into meters. So 10 divided by 100 is 0.10 and 5 divided by 100 is 0.05. So that's how you convert that. And then finally, you got the answer of 20,000 Pascal. Now, for the minimum pressure, you have to use maximum area. So the maximum contact area is this one, 20 into 10. So this is your maximum contact area. So it's like 0.2 into 0.1 because you have to divide it by 100, like 20 divided by 100 is 0.2 and 10 divided by 100 is 0.1 to get the area. So your answer is 5,000 Pascal. So the minimum pressure is 5,000 and the maximum is 20,000. Next topic is liquid pressure. Well, it's so interesting. The liquid pressure is like when you go into the sea water or when you go into the underwater swimming in a swimming pool, then you can experience some sort of thing pushing you down. That is actually the water which is on top of you. So the pressure exerted by liquid on objects immersed in them is known as liquid pressure. Like whatever thing you immerse in the liquid on top of that object is going to exert a pressure that is known as liquid pressure. And its equation is P equals rho GH, where P is the liquid pressure symbol, its unit is Pascal. Rho is the density of the liquid symbol, its unit is kilogram per meter cube. G is the gravity, which is measured in Newton per kilogram, and H is the depth in the liquid that is measured in meters, like how deep the object is inside the liquid. Well, the factors, it comes from the equation. So pressure is directly proportional to density of the liquid and pressure is directly proportional to depth of object in the liquid. Well, I hope you understand what is meant by direct proportionality. It means that if you increase density, then the liquid pressure will increase. Or if you decrease the depth of the object in the liquid, the pressure is going to decrease. Okay, let's move forward to see some examples over there. Well, there are three containers, X, Y, and Z, and three of them are filled with different liquids. Liquids of different density, like for X, the density is rho X, for Y, it is rho Y, and for Z, it is rho Z, and rho Z is the having greatest density. Well, the height is same for all, the height is same, G is same, and you know that pressure is directly proportional to density. So as the liquid Z, the black one, is having the higher density, that's why its pressure will be maximum on the base. And as the liquid X is having the least density, so its pressure will be minimum on the base. Let's look on example 2, where we have to use the same liquid, like with the same density as the bluish color, but the height is different. For X, it is H1, which is maximum. For Y, it is H2, and for Z, it is H3. So as X is having the greatest height, so that's why the X pressure is highest, and X as Z is having the least height, that's why its pressure is least. Okay, moving forward to another example. Well, there are three containers again, and all of them are filled with different liquids. Let's say X is having density rho, Y is having density 1.2 rho, and Z is having density 2 rho. So Z is more denser. But X is least dense, but its height is maximum, which is 10 centimeter. The height of Y is 8 centimeter. The height in Z is 5 centimeter. So what you have to do is you have to find maximum and minimum pressure due to the liquids from X, Y, and Z on base of the containers. Like which of one of them is having the greatest pressure, and which one of them is exerting the least pressure on the base. So we know that pressure is rho GH. So now what we'll do is pressure due to liquid in container X is rho GH. So rho is rho and G is 10 and the height is 10 centimeters. So we divide that by 100 to convert that into meters. So when you do the maths, so the answer is 1 into rho. Okay, for Y, you have to put rho GH, so rho is 1.2 rho Y, and height is 8, so divide it with 100 to convert it into meter, and G is 10, so the answer is 0.96 rho. For Z, the density is 2 rho, the depth is 5 centimeters, so 5 divided by 100, and G is 10, so the answer is 1 rho. It means that maximum pressure is exerted by both X and Y because the answer is same, 1 rho, and the minimum pressure is exerted by Y because it is 0.96. Okay, moving forward to another example, you can pause and you can do it yourself. There's a container filled with liquid and its depth is 10 meter. And then there are two balls, same ball in two situations, one at Y and one at X. At Y, its depth is 2 meter, like depth from top of the ball to top of the surface. Okay, so the diameter of ball is 50 centimeter. Find the liquid pressure on top of the ball at point X and point Y. Okay, let's do first with point Y. We know that rho P pressure is rho GH. So the rho is given, which is like 1050. Okay, G is 10, and the depth at point Y is 2. So your answer is 21,000 Pascal. Okay, fine. Now let's find pressure at X. So at X, it is rho GH. So rho is 1050, G is 10. But for H, you would not be using 10. Why? Because 10 is still the base. You have to measure the height from surface to top of the object. And as the ball is having a diameter of 50 centimeter or 0.5 meter, so obviously you will be subtracting 0.5 from 10 to get the height, which is 9.5 meters. That was the only point, analytical point over there. 10 minus 0.5, since height is measured from top of the liquid surface to top of the ball. So the answer is 99,750 Pascal. Okay. Now let's look upon another pressure, which is atmospheric pressure. And well, that is actually the most important pressure for us because we have to live we have to live our whole life on the surface of the earth, where the earth and its surface and all the objects are surrounded by air particles. So you know that these air particles, the gaseous particles, are moving randomly and continuously. So when these energetic particles collide with the objects in the atmosphere, then they exert a pressure on them, which is known as atmospheric pressure. So the formal definition is pressure due to collision of energetic air particles with objects in air is known as atmospheric pressure. Well, talking about its standard value, which is measured at the sea level, and its standard value is 1.01 into 10 to the power 5 Pascal or 100,000 Pascal at the sea level. And again, atmospheric pressure is inversely proportional to height from the sea level. Inversely, it means if you move away from the sea level, then the atmospheric pressure is going to decrease. Let's look this in an example over here, that here is the sea level, and then this is the land level, and this is the mountain. So on the sea level, the pressure is 100 kilopascal. On land, it is 96 kilopascal. And at the top of mountain, it is 70 kilopascal. Because as you move away from the sea level, the air density is going to decrease, and so does the atmospheric pressure. So the atmospheric pressure is highest at sea level, then at the land, and it is minimum on the top of the mountain. Okay, the next thing is again very interesting. It is barometer. Well, barometer. Barometer is atmospheric pressure measuring device. Like if you want to measure how much is the air pressure right now in your room, so you need barometer. Okay, so inside the barometer, we will be using simple mercury barometer. Why it is known as simple? Because its construction is very simple. It only consists of 1 meter long glass tube and then a beaker full of mercury and then a scale and ruler. See how simple is it? That's why it is known as simple mercury barometer. Simple due to its simple structure, and mercury because mercury is used in it, and barometer because it is an atmospheric pressure measuring instrument. It is used to measure the atmospheric pressure. Okay, now the big question is how? How to measure atmospheric pressure? Well, this is interesting. This is the technique. Okay, like how to drive a car, how to get good grade in exam, how to look for good food. Like there are many things that we keep on doing in our life. So over here, we have to see that how to measure atmospheric pressure using the simple mercury barometer. Well, the technique is quite simple. In the diagram on the right, there's a barometer that consists of three things. The jar is there. Okay, the jar, which is at the bottom, and then the tube, 1 meter long glass tube, and then the pink thing is actually the mercury in it, and then 1 meter rule is over there. Okay, so on the surface of the jar, the air is exerting the pressure that we have to measure. In the liquid, in the tube, the liquid columns are A, B, and C points. And then above A is the vacuum. It means no air is there. So how you will measure the atmospheric pressure? You have to do very simple thing. What you have to do is you have to measure the length between highest mercury levels in the tube to the highest mercury level in the jar, right? So just measure the height between them. Which height? This height. The height from the jar to the top level in the tube. That's it. Just measure it. And then you have to use P equals rho GH, where rho is the density of the mercury, G is 10, and H is the height that you have measured to measure the atmospheric pressure. Well, the unit for atmospheric pressure, the first unit is Pascal, that is P equal rho GH. Rho is the density of mercury, G is gravity, and H is the length between two mercury levels, like the one in the tube and one in the jar. So you can get your answer in Pascal. The second unit is millimeter Hg, where millimeter stand for the length and Hg stand for mercury. So what you have to do is you just have to measure the length of mercury column in the tube and express it as the answer. Like the length should be in millimeters usually, and Hg is meant for mercury. So for example, the standard value of atmospheric pressure is 760 millimeter Hg, or it is 76 centimeter Hg, or it is in Pascal equal to 1.01 into 10 to the 5 Pascal. Now let's look on the pressure due to on an object due to liquid and atmosphere, like the combined pressure. So the combined or total pressure acting on object is equivalent to liquid pressure plus air pressure. So the total pressure is rho GH plus P naught. So it is used to find the total pressure acting on the object submerged in the liquid. Okay, now let's look at an example. There's a submarine in the water as shown. The submarine is 50 meter deep in the water, and its door area is 0.8 meter square, and the density of water is 1020 kilogram per meter cube, and the air pressure acting on top of liquid is 100 kilopascal. So what you have to do is you have to find the liquid pressure acting on the door. So that's quite simple. You will be using rho GH for liquid pressure. Rho is 1020, G is 10, and the depth is 50. So that's how you will get your answer. So you just have to do some maths, some calculations to solve this. It's taking long. Okay, so, well, 510,000 Pascal. Okay, the total pressure acting on the door. So the total pressure is liquid pressure plus air pressure. So 510,000 plus 100,000. So the answer is 610,000 Pascal, or it is 610 kilopascal. That's the total pressure that is being exerted on the door of the submarine. The next question is you have to find the force acting on the door. So you know that pressure is force over area. So from here, force is pressure into area. So as the total pressure is 610,000 Pascal and the area is 0.8, so just multiply them together, you'll get the answer. So the answer will be this, Newton. So like this is 488 kilonewton, 488 kilonewton force is acting on the door. If the weight of door is 350 Newton, find the minimum force to open the door in the water at this depth. So let's say if this is the door, its weight is downward and the water force is also acting downward, which is like 488 kilonewton, that is too much. And the weight is 350, which is like 0.35 kilonewton, like 350 divided by 1000. So in order to open it up, you have to apply an upward force. So you know that the upward force should be equal to the minimum downward force, force due to liquid plus its weight. So that is like 488 plus 0.35. So we can say 488.35 kilonewton. This is the minimum force that is required to lift the door up. Okay, now the last topic for this is manometer. Manometer is a device used to measure gas pressure or steam pressure in the container. It is used to measure density of the liquid as well using the pressure method. So it is basically used to measure the gas pressure and the density of the liquid. So let's look upon that. It basically consists of a U-shaped glass tube with both ends open. If you want to measure the unknown pressure of the gas or steam, what you'll do is you will keep one end open, like this end is open, and then what you'll do is you'll connect the other end with that object for which you have to measure the pressure, like the gas or what. Okay, then what you'll do is you will measure the height difference between the two liquid columns. You know, there are two liquid columns, and then there is a height difference between them. Just measure that and then use the formula P equals rho G H, where this delta H is the height difference. Put the values to measure the gas pressure. The next one is measuring the density of the liquid. Well, again, it's a U-shaped tube. So what you'll do is you have like two liquids. One is the water. You know its density, which is 1000 kilogram per meter cube. The other one is oil, and you have to measure its density. So what you'll do is you'll pour the both liquids, which are immiscible, like they're not thoroughly mixed, into U-shaped manometer from separate ends, like water from this end and oil from this end, right? So from this end, you're pouring water, and from this end, you're pouring oil into it. Then you have to mark the horizontal line from pivot where two liquids are in touch. So where two liquids are in touch, like water and oil, you have to draw this horizontal line. Then you have to measure the height of both liquid columns from this horizontal line. Like you have to measure how much is the height of this, which is 10, and how much height of this, which is 4. And then you'll be using this equation. Pressure at point X is equal to pressure at point Y, because both levels are at same, and in liquid at same level, pressure is always same. So pressure at X is equal to pressure at Y. So rho X GHX equal rho Y GHY. So you will put the data over here, as rho Y is unknown. So you can find that easily, like G and G cancel away, and rho Y equals HX over HY into rho X. So that's the equation to which we can find unknown density. Now we have to solve some past paper question, but what we will do is I will share the questions with you. Okay, so now we have to solve some pressure questions. So let's first read this question number 1. Okay, a large stone block is to be part of the harbor wall. The block is supported beneath the surface of the sea by the cable from a crane. Figure 2.1 shows the block with its top surface at a distance h below the surface of the sea. Okay, the force acting downwards on the top of the block due to the atmosphere and the depth h of water is this. Like this is the total force which is acting over here, which is 3.5 into 10 power 4 Newton. The top face of the water block has an area of 0.25 meters square. Calculate the pressure on top of the block. That's quite simple. They gave you force, they gave you area, like these two things are given, and they demand pressure from you. So that's quite simple. Pressure is force over area. and the force is like 3.5 into 10 power 4, and area is 0.25. So you'll get the answer. And over here, the answer will be 14 into 10 power 4, or 1.4 into 10 to the power 5 Newton. That's the answer. Okay, now let's look upon the next part. The atmospheric pressure is 1 into 10 to the power 5. It can also be written as 100,000 Pascal, or it can also be written as 100 kilopascal. So calculate the pressure on top face due to depth h of the water. So now we know that total pressure is equal to liquid pressure plus atmospheric pressure. So as the total pressure was given over there, which was this one, 1.4 into 10 to the power 5, and the liquid pressure is, you have to find liquid pressure, okay, and atmospheric pressure is 1.0 into 10 to the power 5. So you'll do a bit of maths. You will subtract these two, like shift atmospheric pressure to other side. So the answer would be 0.4 into 10 to the power 5. That is your answer. The next is density of seawater is 1020. Calculate the depth h. So now you know that the liquid pressure, this is the liquid pressure. So the liquid pressure is rho gh. And from here, the depth is pressure over rho g. So the liquid pressure is what you have calculated, 0.4 into 10 to the power 5, and the density is 1020, and G is 10. So what you can do is you can easily find the value over there. Okay, so you can calculate it. Okay, next, suggest 2 reasons why the tension force in the cable is not 3.5 into 10 to the power 4. Like what was 3.5 into 10 to the power 4? It was this. Like this is the total, the force. This was the total force due to atmosphere and due to depth. So they're saying that why the tension in the cable is not this. Well, this is due to upthrust force, as water is also applying a force on the block which is in upward direction. So upthrust force is the first reason, because this force is acting on the block in upward direction. So that's why it is holding the block up a bit. So that's why the tension in the cable is not similar to the total total force which is acting on the block. Okay, the second one, because we have to tell 2 reasons. So what's the second reason? The second reason is atmospheric pressure may be different. So maybe there is slight variation in the atmospheric pressure. That's why the value is not the same. Okay, the block is lowered so that it rests on the seabed. State what happens to the tension force in the cable. Well, when the block is resting, so the tension is, of course, decreases. So tension will decrease, because now the normal reaction force will be acting, so then the tension will be decreasing. Okay, now let's move on to another question. Okay, this one. Mercury is poured in a U-shaped glass tube. Water is then poured into one of the limbs of the tube. Oil is poured into the other limb until the surface of the mercury are same in the both limbs. Okay, so now like 3 things are there. This is the mercury, which is having the same same level, and then water is in one limb and oil is in other, and the heights are given. Like this is the height of the water and this is the height of the oil. So what they're asking you to do, state a condition that must be true in order for a murky surface to be at the same level in both limbs. So what is the condition that this mercury in the both limb is at same level? The pressure, same pressure acting on mercury in both limbs. So when same pressure will be there, then only then the mercury can be at same level. So the height of water column is 0.25 and the height of oil is 0.32. and the density of water is 1000 kilogram per meter cube, what you have to do is you have to calculate the pressure exerted by water on the surface of the mercury. That's quite simple. Pressure is rho Gh. So the water density is given, which is 1000, G is 10, and the depth of water is 0.25. So just multiply them, which is like 2500 Pascal. Yeah. Okay. Then you have to find the density of the oil. So we know that at same level, pressure is same. So pressure due to oil and pressure due to water is same. So we say, okay, pressure due to water is same as pressure due to oil. So pressure due to water is 2500 Pascal. And pressure due to oil is rho oil into G into H. So as you have to find density of oil, so what you'll do is you'll shift G and H on the other side. So it is like 2500 over 10 into depth, which was 0.32. So you'll do the maths to get the answer. So I hope, students, that this video lecture might be beneficial for you. So thank you so much. I'm going to share these worksheets in the description link so that you can solve the other questions as well. Take care until the next video. The next video is about thermal physics. It's about thermal physics. See you then. Take care.